Hey guys, welcome back to our last live lesson. I'm going to go over the projectile motion and quadratic applications. If you attended the first video or you've watched the first video, some of it might be repeat, but the examples that I use are different. So you will end up with all 5 of the questions from the Google form. All right, so when you're looking at a quadratic graph, when we're talking about projectile motion, they are usually upside down parabolas, meaning that the value of A is negative. It's because if you're throwing a ball or something, it has that kind of arc to it. So here's a soccer ball. It looks like it's being thrown. At the y-intercept is where the ball started, so it must have been like above somebody's head. And then they threw it and it rises, and then all of a sudden it drops. So its highest value is at its vertex, which in this case is a maximum value. The time it's been is the x value, and the height of the ball at its highest location is the y value. When the ball hits the ground is the next 0 or x-intercept, and it's usually always the positive 0. Okay? Real quick, I'm going to put a plug in there for Desmos. If you haven't already downloaded it as an app or gone to the website, it's completely free and it's super helpful in this unit. Since it's my birthday, I'm not going to work these out long form because we have the capability of Desmos and graphing calculators. So I just want you to understand how this equation works and how you can find what you need from the graph. So our equation is h equals negative 4t squared plus 2t. So I'm going to go over here to Desmos, and I typed it in, but I had to replace the t's with x's because you cannot graph with the t values in there. Okay, so then here's my graph. I think we're talking about a person jumping off the ground. So she was standing on the ground. She jumped. Here's her highest point, and then she landed back on the ground. Okay. Remember, your x is time and your y is height. So at 0 minutes, she was standing on the ground. Then she jumped, and her highest point was at 1/4 of a foot, and that was 1/4 of a second. And then she landed 1/2 second later, and she's back on the ground. That's why her y value is back to 0. Okay, so let's look at the questions. It says, how long was your friend in the air? Well, she was in the air for 1/2 second. And if you type these in and it tells you you're wrong, don't stress about it. I do go back and give you points for the ones where sometimes it's a typo, sometimes it's just picky about how you type it. How high did your friend jump? At their highest point. So we're going to go back to the graph and we're going to click on our vertex, and the y value is height, so 1/4 of a foot because the question was in feet. So you can either put it as a fraction or as a decimal. It does not matter to me. And then lastly, when did she reach her maximum height? So her maximum height and what time did she reach it? A 1/4 of a second. So each time do include your units. It's okay if it doesn't like your answer. I will go back and edit it so that it fits. And then there you go. Okay, let's move to the next question. A Jesus Christ lizard is jumping across the water in search of food. The equation h equals negative 12t squared plus 6t models the lizard's height in feet above the water t seconds after he jumps. So they use h to represent height and t to represent time, but we're going to switch it to x and y. So on my graph, I actually already typed it in for you guys. And if you're on the Desmos graph, you can scroll up with your mouse or scroll down with your mouse to zoom in and out. It's super helpful. But also, if you just click on the vertex, it'll lock those points on your screen. Okay, So we're talking about a lizard, and the lizard starts on the ground, jumps, and then lands, okay? So question A is asking, how long after jumping is he back on the water? So they want to know how long was he in the air and then land. So that's going to be our x-intercept because the ground is on the x-axis. So a half a second. So he was only out of the water for a half a second. How high is each jump? So looking here, what is his highest y value, which is the 0.75, because that's the height. Remember, the x value is time, and that's 0.25. So the 0.75, or 1/4, is what our b value is going to, or our b answer is going to be. 3/4 feet. And then we're looking at how long does it take to get to the highest point. So what was the y value of his highest point? The 0.25. So let's go ahead and put that there. Okay, any questions so far? Awesome. And then the last example on the Google form is your cousin hit a golf ball with an initial velocity of 27 feet per second. The equation h equals negative 6x squared plus 27x models the golf ball's height in feet t seconds after the ball was hit. I already changed my t to x because it's just habit. So they're asking how long was the golf ball in the air, how high did the golf ball get, and how long after being hit did the ball reach maximum height. So basically the same three questions. I'm going to come over here because I already have that graph ready. Notice how I can't see my vertex. So I'm going to zoom out. You can even like click and drag on the computer screen to get everything into one picture. I'm going to click up here on my vertex and it's going to lock it. Click on my zeros. So we have the golf ball, it started on the ground, he hit it, it got up here to 30.375 feet, 2.25 seconds after he hit it, and then it landed back on the ground 4.5 seconds after he hit it. And since it's the ground, that's why your y value is 0. So coming back over here, how long was the golf ball in the air in total? So the golf ball stayed in the air 4.5 seconds. How high did the golf ball get? What was the highest value that it had in the graph? So remember, x is time, y is height, so 30.375. 30.375. If you rounded it, I did go back, feet. I did go back and give you credit if you rounded. And then how long after being hit did the ball reach maximum height? So what was the x value of our maximum? The 2.25. Which you'll notice is always half of your total time in the air, because since it's a parabola and it has that axis of symmetry, it has to be half of that. All right, well, hopefully that was helpful. It definitely at least gave you 9 answers that you need for your Google form. That's really all I have for you today, because the other one was the discussion post where there's not a wrong answer. So just be sure that you answer it and tell me which one you feel like doesn't belong, and use the vocabulary to tell me why. Other than that, have a great summer. I miss you guys a lot. Take care.